So today we're going to be looking at 9.2, which is analyzing rational functions. So if you did the 9.1 graph lab, again, these will start to look a little bit familiar, but if you have not, most of these will look completely new. In grade 11, you looked at rational functions and graphing using always a horizontal asymptote on the y-axis, and vertical asymptotes were your non-permissible values from the denominator of your function. So just a reminder, a rational function is of the form p of x over q of x, where p of x and q of x are polynomial functions. In other words, it's a fraction where you have some sort of polynomial on the top and on the bottom. So your non-permissible values, you're always looking at the denominator. And remember that these are where your denominator would equal 0. You're not allowed to have a denominator of 0. So you would be looking for what values would make that happen, and those are non-permissible. So far in grade 11, these always created vertical asymptotes, and that's specifically because of the types of equations you were given. There is another situation where they don't create vertical asymptote. They create something called a hole. So what a hole looks like is if I'm bopping along my function and then all of a sudden I have a point that doesn't work and then I keep going. You might have seen functions that look like this before. When you worked in Desmos, it doesn't actually show you this hole, but if you hover over that point, it will say undefined, meaning there is no x value there. All the x values around where we have the solid line work, but at that specific point, it doesn't happen. There's nothing there. Vertical asymptotes you saw as well in grade 11. Your vertical asymptotes were things like if you had a vertical asymptote here, then your function might have looked like this and like something like that. The vertical asymptotes happen when the denominator is not a factor of the numerator. Okay, so sometimes you might have multiple factors on the top and multiple factors on the bottom. If there's a factor on the top and the bottom that are the same, this will create a hole. If they are not the same, this will create a vertical asymptote. The same factor cannot create both. It's one or the other. So a common mistake people make here is they say that, say, x is -5 is a hole, but then they say it's also an asymptote. That can't happen because you, of course, can't have a hole on an asymptote. There's no values anywhere on the asymptotes. That's what an asymptote is. So it's one or the other. Okay. Another term you might see for a hole is discontinuity. Okay, so you might see this being called a point of discontinuity. If you plan on taking calculus, you deal with that discontinuity word quite a bit. Okay. Horizontal asymptotes. Last year, you only had a horizontal asymptote ever on the x-axis. This is because all of your functions looked like case 1 below. You had 1 over something for every function you dealt with. Okay. So a horizontal asymptote will happen when the degree of p of x, or the degree of the numerator, is less than or equal to the degree of q of x, or the degree of your denominator. My pen is having a little bit of issues writing. So an example would be y equals x plus 2 over x squared plus 6x plus 5. The degree of the top is 1. The degree of the bottom is 2 because of the x squared. So this one, you would end up with a horizontal asymptote. Okay. Another example would be something like y equals x plus 2 over 3x plus 5. Again, the degree of the top is 1. The degree of the bottom is also 1 because the highest power of x you have on the top and the bottom is 1 for both. So this would also result in a horizontal asymptote. Your oblique asymptote happens when the degree of the numerator, or P of x, is greater than the degree of the denominator, or Q of x. An oblique asymptote means your asymptote is a diagonal. It's a slanted line. Okay, so it's not straight up and down or straight side to side, it's on a slant. Okay, so an example here would be if you had y equals x squared plus 9 over x minus 4. Okay, this one is not going to have a horizontal asymptote. It will have a vertical asymptote and an oblique asymptote. Okay, so you can have a vertical asymptote and a horizontal asymptote, or a vertical asymptote and an oblique asymptote. Okay, but you cannot have a horizontal asymptote and an oblique asymptote at the same time. That's not possible. Okay. The first thing you are always going to do for every question is factor the numerator and factor the denominator if you can. It's not always possible. Sometimes they don't factor. And you're going to check and see if you have any common factors, because that will result in a whole. If you do, you will deal with that first and then you will move on. Okay. So we're going to look at each case here, whether the degree is bigger on the top or on the bottom, or if the degrees are the same. We're going to look at how these different cases work algebraically and then what they look like on a graph. So our first question says the degree of P of x is less than the degree of Q of x. So the degree on the top is smaller than the bottom. So if I look at the top, this has a degree of 0. On the bottom, your degree is 2. I can't factor the top, so there's no factors, which means there are no wholes. So next, I can determine any non-permissible values, which must be vertical asymptotes. Okay. So my non-permissible values here are what can x not equal? What x values would make the denominator 0? Because that's not possible. So our non-permissible values would be plus or minus 2. If I plug in either of those, I'm going to get 0 on the bottom, which is not possible. And these are both going to be vertical asymptotes. And we write that as x equals 2 and x equals negative 2. We say x equals because they are equations of a vertical line. Okay, no common factors between the top and the bottom, so no holes. Okay. Now, this means that we're going to have a vertical asymptote at 2. Remember, we usually draw these in with a dashed line, and another one at negative 2. Again, another dashed line. So this is 2. This is negative 2. Okay. And then the next stage is to determine horizontal asymptotes. So the first thing I need to do is I know that if I have the degree of the top is less than the degree of the bottom, degree of numerator is less than denominator, then I'm going to have a horizontal asymptote. Okay. So degree of numerator is less than degree of denominator. So this tells me horizontal asymptote, not oblique asymptote. And the question is where? Okay. If the degree on the top is less than the bottom, not equal to, but less, my horizontal asymptote will always be at y equals 0. Okay, and this is because I have a degree on the top strictly less than the bottom. There's no way we can ever reach a y value of 0 here. I always have 1 over something else. There's no way I can get 0. Okay, so once I know that, I can draw in my asymptote. And this is actually a question you would have seen last year, a question like this. Once you do that, the only way to figure out where all your points go is to pick x values and plug them in and find out what y values you would have. So for example, if I plug in an x value of 0, I get -1/4. If I plug in x value of 1 or -1, I get -1/3. And so this, we know from last year, is going to be this upside down U looking thing. Okay? It can't go up because it would have to cross the asymptote that way, which doesn't work. Okay? Then I might pick maybe when x is 3 and -3 would be a good idea. So if I plug in 3, I get 1/9 minus 4, or 1/5. If I plug in -3, I also get 1/5. And again, we know that generally this looks like two sort of L-shaped hockey stick looking things. Now, I'm not super picky about exactly where all these points go. If I wanted to be that picky, I would ask you to do it on Desmos or on a graphing calculator. You are not a calculator. What I'm looking for here is, do you know the general shape that you should have? Do you know if you have holes or vertical asymptotes, and where are they? And do you know where your horizontal asymptote should be? I'm not super concerned with the exact location of all these little points that I just drew. I want to know, is the shape right? Are the asymptotes right? And if there were holes, did you identify where those are and put those on your graph? The next case we're going to look at is when the degree of the top equals the degree of the bottom. Okay, so we know from our big chart up here, if our degrees are equal, we're going to have a horizontal asymptote. Okay. I also need to see if there's any common factors. So if I factor the top and the bottom here, I get x plus 2, x minus 2 on the top, and I get x plus 3, x minus 3 on the bottom. No common factors, meaning no holes. My non-permissible values here, bottom would be x can't equal plus or minus 3, which means my vertical asymptotes on the bottom would be x equals 3 and x equals -3. So I'm going to draw in my asymptotes. Okay. Again, no holes because we had no common factors. Okay. Next, we need to determine where the horizontal asymptote lies. And so this is where we are going to start having new stuff here. Last year, you always had 1 over something. You always had where the degree of the top was less than the degree of the bottom. This is a new thing this year where you have a degree of the top equals the degree of the bottom. When we talk about an asymptote, what we're really talking about is what happens as we head towards infinity or negative infinity in some direction. When I'm talking about a horizontal asymptote, what I'm really talking about is as we head off on our graph to the right forever or to the left forever, off to infinity or to negative infinity, what happens to my y values? What am I going to get very close to? Or am I going to shoot off into infinity forever, up or down forever? Okay. So if I think about, I'm going to plug really, 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 really big values of x in here, what will happen is similar to what we looked at in the conic sections chapter, 4 on the top and the 9 on the bottom stop mattering. As x gets very large, so towards infinity, or very small, the -4 and the -9 stop mattering. So what happens is we really end up with almost like a y equals x squared over x squared situation. And this simplifies to be 1. This means that as x gets very, very big or very, very small, they essentially cancel each other out, and we end up heading towards 1. Okay? This means our horizontal asymptote is at y equals 1. Okay? So if the degree of the numerator is equal to the degree of the denominator, what you're really looking at is the highest power of x on the top and the highest power of x on the bottom, and you're going to look at the coefficients. So if I had something, maybe you could write this down if you want, but you don't need to. If I had something like y equals 3x squared minus 2 over 5x squared plus 5x minus 3, Again, as x gets very, very large, the -2 stops mattering, so the top becomes almost like 3x squared. On the bottom, the 5x and the -3 stop mattering, so the bottom becomes like 5x squared, which would equal 3 over 5. So this is where my horizontal asymptote would be. So really what it is it's the coefficient of the numerator, highest power, and the coefficient of the denominator, highest power, 5. That's for our horizontal asymptote. Only if the degrees are equal. So now that we know that, we put our asymptote in at y equals 1. And again, in order to actually graph this thing, we're going to need to plug in some x values. You can make yourself a table of values if you'd like, or you can just kind of do it in your head. So if x was 0, I'd have -4 over -9, or 4 over 9. If x was 1, I'd have -3 over -8, or 3 over 8. That's not going to be much of a difference. I'm not going to put those on there. We know that if x is 2 or -2, the top would be 0, which makes the whole fraction 0. And so we end up with points there. We can connect those. Okay. Then I might want to pick maybe when x is 4 and when x is -4. So if x is 4, on the top, we end up with 16 minus 4. On the bottom, we end up with 16 minus 9. So we get 12 over 7, or 1 and a bit. Okay. So about here, and then we can draw in our 2 here. So if the degree on the top is less than the degree on the bottom, your horizontal asymptote is at 0. The only way your horizontal asymptote will be somewhere else is if the degree of the top and the bottom are the same. And then you're going to look at the coefficients of that degree of that term. So we'll try another one. So here we have, again, no common factors. My possible value would be the bottom x can't equal -3, which makes this a vertical asymptote. No common factor, so no hole. Okay. I have an equal degree on the top and the bottom. So as x goes towards infinity or negative infinity, it gets very, very big or very, very small. Y will equal 2x over x, which is equal to 2. So therefore, I have a horizontal asymptote at y equals 2. So I can put all this on my graph. I have an asymptote at -3 and an asymptote at 2. And again, I'm going to have to pick some values to plug in and try and figure out where my curves are going to go. So if you recall from last year, you end up with curves that are sort of like kitty corner to each other. So either top right, bottom left, or top left, bottom right. They can't be like over top of each other. So let's pick, I like to pick 0 if I'm allowed to. So if I put x is 0 in here, I get 0 over something, which is 0. Maybe I'm going to pick maybe x is -2 or something as well. If I plug -2 in here, I get -4 on the top and 1 on the bottom. And maybe I'll pick when x is maybe 1 as well. So if I plug 1 in, I get 2 on the top and 4 on the bottom, or a half. And this is good. We can 3 points is fine. And then over on the left, maybe I'll pick -4. -4 would give me -8 over -1, or +8. That's off my grid, so maybe I shouldn't have picked that. If I do -5, I get -10 on the top, -2 on the bottom, which gives me 5. Pick that one. Again, if you want to actually draw yourself a table, if that makes it easier, then you can. So how do you determine the equation of the horizontal asymptote? If the degree here is less than the degree of denominator, then your horizontal asymptote is at y equals 0. If your degree of the numerator is equal to the degree of the denominator, then you need to look at the coefficients of the highest power. Okay, and your horizontal asymptote would be at y equals the coefficient of the top highest power over the coefficient of the denominator's highest power. So the last situation would be, well, what if the degree of the numerator is bigger than the degree of the denominator? If that happens, you're going to have an oblique asymptote. Okay, so if we take a look at this next one, the degree of the top is 2, the degree of the bottom is 1. I have no common factors, so my non-permissible value is x can't equal -2. This is going to be a vertical asymptote. Now, next, we need to find the equation of the oblique asymptote. So if you did not take a look at the extra chapter 3 stuff, this is going to be difficult to do. Basically, what you need to do is divide these two polynomials, which is from section 3.2 and 3.3 of the year. So if you haven't taken a look at those yet, this part of the section will not be possible. But what we need to do is divide. So if you have taken a look at those, keep moving on. If not, I would fast forward into the examples from the back page and sort of ignore this for now. This specific portion is pretty much one of the only portions in this lesson that you would not need for calculus. So calculus, we don't usually deal with oblique asymptotes at all. So if you are planning on taking calculus and you didn't do the dividing part, and you don't want to or don't have time to, just skip this example and move on to the last page of it. But if you did, then you could move on. So as soon as you have an oblique asymptote, you need to divide the fraction. You need to actually divide this thing. So if you're using synthetic division, you would have a 1, a 0, and a -3. And your 0 from your fraction is -2. So this is from your x squared. There's no x terms, and this is your -3, right? So you're going to bring down the 1, multiply, and you get -2. When you add those together, you get -2, multiply, and you get 4, add those together, and you get 1. So you end up with x minus 2, remainder 1. We ignore the remainder. The oblique asymptote is therefore x minus 2. Again, we're ignoring the remainder because as x gets very, very large, that remainder stops mattering. Okay? So my oblique asymptote is the linear equation y equals x minus 2. It is a straight line that is diagonal. So when we draw it in, we're going to draw it in like we draw a normal line. Okay? We would have an x-intercept, or sorry, a y-intercept, therefore, of -2, and you have a slope of 1. And you're going to draw that in. Okay, so you have x equals -2 as your vertical asymptote, and y equals x minus 2 as your oblique asymptote. You could also do long division. Okay, long division would be fine as well. If you do long division, you will end up, you will have x squared minus 0x minus 3, or plus 0x, doesn't matter. You have x plus 2 as your factor. So you're going to start with an x, get x squared plus 2x. This gives you minus 2x. Bring down the -3, minus 2. You get minus 2x minus 4. You subtract those, you get 1. So you get equals x minus 2 with a remainder of 1. You get the same answer. Work is different. Doesn't matter which method you use. Again, now we need to pick some x values and plug in to actually draw a graph. We have the asymptotes, but we don't have a curve. So if I pick x as 0, I get -3/2. If I pick x as 1, I get -2/3. And I could keep going that way. If I pick x as -1, I get -2 over -1, which gives me, I get -2 over +1, which gives me 2. And so this is not going to be a straight line. What's going to happen is this is going to head towards our asymptote this direction. And it eventually, what happens is it gets too close to the asymptote the other direction. It has to head up this way. Our other one, we probably need one value, maybe at x is -3, get 9 minus 6 over -1, -6 here. And this one goes here. So again, these ones always go kind of kitty corner to each other. So either these two sections or these two sections is where you would end up, okay? And again, if you are looking at this dividing stuff and going, I didn't do 3.2, 3.3, those were optional, I didn't look at them, no idea what's going on, don't worry about this section, move on past case 3 to the last page. You won't need this for calculus. Fine. So try the next question if you've been following along. Maybe pause the video, and then you can take a look at the answer for the next one. I'll just give you a moment to pause here if you need. Okay, if you're either continuing on or coming back, again, if we want, we can try and factor the top here. Not possible. I'd have to find two things that multiply to be -1 but add to be -2. Can't do it. So my non-purposeful value at the bottom would be x can't equal -1, and this is a vertical asymptote. Again, there's no common factor, so therefore no hole. Okay, I have an asymptote at -1. And then I need to determine my equation for my oblique asymptote. The degree of the top is bigger than the degree of the bottom. So I've got 1, -2, and -1. And then my x value is -1. Bring down the 1. I get -1, -3, 3, 2. I have x minus 3, remainder 2. Again, I'm going to ignore my remainder. Therefore, my oblique asymptote is at y equals x minus 3. This is a dashed line with an intercept of -3 and a slope of 1. Again, in order to actually graph this thing, we would need to pick some x values and plug them in. I like to plug in 0 if I can. If I do 0, I get a y value of -1. I'm going to pick x is 1. I get 1 minus 2 minus 1. This gives me -2 over 2. This also gives me -1. Again, I know that this has to head off towards my asymptotes. Put that in. If I pick -2, I get 4 plus 4 minus 1. That gives me 7 over -1, -7 here. Again, long division would be fine as well, but I find most of you guys seem to like doing synthetic. So long division is okay too. I showed long division on the PDF online. So in short, how do you determine the equation with of an oblique asymptote? You need to actually divide the numerator by the denominator. From chapter 3. So none of these questions have had holes. So the question is, when do we have a hole? So a hole happens when you have a common factor between the numerator and the denominator. So in other words, if we factor the top and the bottom of our rational and there's a common factor, we have a hole, and that's where that will happen. This can happen in any of these three cases as long as there's a common factor. So for example, if we have x squared plus 3x minus 4 over x minus 1, most people would look at this and go, hey, okay, we have an oblique asymptote and a vertical asymptote, and I'm going to divide, and away we go. No, our first goal is always factor and see if there's a common factor. Okay? So if I take a look at this, if I factor the top, I get x plus 4 and x minus 1 all over x minus 1. I have a common factor, so I'm actually going to cancel those out, and I get x plus 4. what often happens is people say, oh, there's my common factor, I have a hole. But they don't cancel them out and they keep trying to graph with an oblique asymptote. You cannot have that same factor be an asymptote and a hole. It's one or the other. So as soon as I have this, I now am left with just x plus 4. This is a straight line, but it's going to have a hole in it. So my non-permissible value from that denominator still exists. I still have that x can't equal 1. But as soon as I've canceled this out, all I have is x plus 4. This is just a straight line. There's no vertical asymptote on a straight line. There's no horizontal asymptote on a straight line. So the answer for these is none. We don't have any. Okay. If you had more than one non-permissible value, and what I mean by that is, let's say I had something like x plus 4, x minus 1 over x plus 2, x minus 1. When I cancel these out, I have x plus 4 over x plus 2. I would have a vertical asymptote here at x is equal to negative 2, and I would have a horizontal asymptote because I still have a rational left. So if I cancel out things, that results in a hole. And then it's almost like I'm starting over with my new simplified version. So my new simplified version here, the x plus 4 over x plus 2, that still has asymptotes, but it would also have a hole. So what would happen is when I graph this, I'd have my asymptote at 2, and then my other one would be at 1. And when I graph this thing, all that would happen is I would end up here as I graph. That's what would end up happening. Okay. So just because you have a hole does not mean you can't have anything else. But because you have a hole, that fact does not result in anything else. Okay. So please note here that this is not always the case. Okay. So I also have no oblique asymptote. So the most common mistake people make here is they draw their actual graph as an asymptote, which makes no sense. So if I'm drawing this graph, okay, I know it should be a straight line with an intercept of 4 and a slope of 1. That's what all x plus 4 is. We've got an intercept of 4 and a slope of 1. Now the problem is that I should have a hole at x equals 1. If I want to find the y-coordinate of the hole, my new equation is y equals x plus 4. So if I plug in x equals 1, I get y equals 1 plus 4, which is 5. This is where my hole should be. So my hole, the coordinate of the hole, is 1 comma 5. So on my graph, I've got two options. I could have done all this algebraically and then go put that in on my graph. But also, I already know my non-permissible value is when x is 1. So here, so if I go up to my graph, I know my hole should be here. Okay, so I actually need to fix up my graph that I drew and put the hole there. My eraser would work. That'd be super helpful. Nope. Okay. Let's try one more time. My eraser's not going to work for me, but you would want to not actually have that inside. You would want it to be essentially, you would want it to go like this, have a hole, and then move on. You don't want that to be filled in any way. You want it to be very clear that there's nothing there. So because my eraser is working, I can't erase it. But no, eraser's not working at the moment. So you would want to draw it where there's an actual hole. So you can draw the whole graph to start and then erase the hole and draw it as an open circle, or you can put a hole on your graph first and build a line around it. That works too. So maybe take a look at the one online for the better drawing, but effectively that's how you get a hole.